All right, so I guess while everyone's sitting down, I am Dan Nix. I am the sole person at Nixworks. I figured the name was fitting because I work on random problems that generally other people don't want to solve, like how do you put together a simple web-based GCS so that we can make a little bit easier UI than just simply going through QGC every time we want to implement a new feature. So maybe we'll just jump right in. I guess before we get started, who all here has built a website, done some kind of REST API architecture before, just kind of general web dev? Okay, cool. Well, we'll start at a pretty low level. We have 20 minutes longer than I thought I had, so we should have time for questions. So definitely stop me if you have a question. I know a lot of this stuff is kind of out of the scope of what a lot of us do working lower level in firmware and PX4. So don't hesitate to ask any questions. I'll do the best I can, but that's not a guarantee that I'll be able to answer all of them, but we'll do our best. So what are we going to learn today? We're going to go through the basics to build each piece of a web-based GCS that's going to use Mavisdk to communicate Mavlink to the drone. We will also just use other kind of general purpose components like standard web dev tools to get this done. So we really just need to figure out two problems. We need to communicate between the web interface and the drone, and back from the drone to the web interface. And we're going to go over some higher level architectural choices of why you might want to go with the web-based GCS over some of the other more traditional options like QGC. What are we not going to learn? There's a lot of complex architecture that you can put together depending on where you put your servers, kind of like just depending on your application, you can do a lot of different stuff with the web. Like some of this can live in the cloud, some of this is going to live on the machine, and in our case today, it's all going to live on one computer and essentially just act like a regular desktop ground control station. We're just going to control it from the internet. We are not going to learn how to make the web page look good. I am definitely not a front-end developer. I know enough to get projects off the ground, but usually it's not too hard to find a React developer who can actually take whatever we end up with and make something that actually looks commercial grade and is actually viable for people to use. And we are not going to touch on security today. All the communications that we're going to be doing are going to be either gRPC, which that's binary, so you could parse those messages apart, but we're not too worried about that. And all of our web communication will be on plain text HTTP. We're not using HTTPS or anything like that, but that's something that you'd probably want to set up if you were moving towards more of a commercial application. So why would you want to build a web-based GCS? Well, show of hands, who enjoys developing new features for QGC? Don't be embarrassed. You can raise your hands. We're not going to hold it against you. No one. So I've done a little bit of work implementing new features in the mission portion of QGC, and I gotta say, it's a bear to work with. There's a lot of code there. It does a lot of things, but a lot of the things that we need it to do are typically not things that it does a lot of things that we don't need it to do, and it makes it harder to implement the features that we do. Because of the way Qt, however you want to call it, is developed, your desktop UI and your business logic are pretty closely coupled. Everything's living in the same program. If you've done any work on QGC at all, you know kind of how big it's grown and kind of the complexity in dealing with it and implementing new features. And also, we might want to do web-based because there's a lot of money being spent on really effective, good-looking web UI. Like, the biggest tech players are not building desktop apps. If they do build a desktop app, a lot of the time, it's just simply a browser hosted in an Electron window or something like that. It's some kind of web viewer because then they only have to write it one time. It's easy to do a distributed deployment because the communications protocols are kind of assumed and built into a lot of web applications. I mean, the assumption for a web-based application is that you're going to be communicating with different pieces across the network. And a lot of those tools are just very simply accessible and easily built in. And finally, it is inherently cross-platform. If you write a website for one browser, say you write a website for Chrome, it might not work on Internet Explorer, but you're pretty good on Safari, Edge. Any modern browser is going to be able to support most of the features that you want to do. This means that you can take your ground control station, and as long as you can put the server somewhere and you can support the network, you can start hooking up a bunch of tablets, laptops, and you can have everyone interfacing with the same backend that's utilizing the same drone, the same information, and you have a lot less state management to deal with. So why would we not want to build a web-based GCS? Well, if you wanted something that simply lives on an Android tablet, a web-based GCS is going to be pretty heavyweight. It works well as a viewer, but it doesn't work well to run the web-based application itself. There's not a great starter code base. I'll say when I first jumped into doing web-based GCSs, the example I started with was the Mavisdk JavaScript example, but there's inherent problems with that. gRPC for the web at that time did not officially support bidirectional communication, which is, or the concept of gRPC bidirectional streams, where data can be passed from the gRPC server to a web page and back. It was easy to get commands from a web page to a drone, but it was really not trivial, and honestly didn't even make it to a point that we were accomplishing any of our like telemetry goals of receiving information back. And there's a pretty steep learning curve. Like a lot of the web stuff that we have seems kind of like black magic. Some of the commands that we do today are going to do huge bits of lifting for us, and it feels kind of weird as a group coming from C++, make files, and embedded development, going up to something where we're going to just trust this application is going to work. And the cool thing is, generally speaking, we can. These systems are supported by Google, Facebook, where the platform we'll be using in particular is React. It's what Facebook is built off of. It's built to be reliable, easy to use, robust, and it looks good. So what is it going to take to build this web-based GCS? Well, kind of like I've been saying, we're just going to use industry standard tools. We really don't need to rewrite any of this. There's one little bit of code that we actually have to create that didn't exist before, but honestly, it's a pretty thin layer. So we're going to start with Mavisdk server to do our Mavlink communication with the drone, and that communicates with whatever else we want it to talk to via gRPC. Show of hands, who's familiar, or is anyone familiar with gRPC? Or, okay, so gRPC is the Google remote procedure call. It's essentially a binary payload that's defined on both the server side and whatever client you want to attach to. The reason that it was picked for Mavisdk server, as far as I can tell, is because it easily binds to like a dozen different languages. If you look through the Mavisdk server spec, they've got bindings to Go, Swift, C++, Python. All of this happens because that's natively supported by the gRPC interface. For our front end, we're going to use, again, standard web tools. We're going to use React. We're going to build it with the same thing Facebook's built off of. It gives us really high performance UI. It gives us good state information. We can really build really cool applications with this. Like pretty much a large portion of the applications that you use every day are built with this, and they go up quickly. They're easy to find developers for because there's a lot of people coming into the web space, a lot more than who are coming into the desktop space. And it's really been optimized because there is a huge financial incentive for Google and Facebook, well, Facebook for React anyway, to keep their developers working and not spending time writing boilerplate code. So really all we need for this to work is a way to communicate from the Mavisdk server to the front end, and we're going to do that by creating a really thin bridge between gRPC and REST. I guess I totally forgot to put in REST. Is everyone familiar with REST, or, okay. I don't want to assume things, but also meant to put that in. So this is basically what we're going to do. We'll put Mavisdk server and this gRPC bridge on the same machine. From that point on, we just have a basic REST API that we can communicate with the React server. And the second that you have a REST API and a React server, you can go find any web developer that you want, and they will be able to do that, or any React developer. Not all web developers are React developers, but it's all, a lot of the systems and the understanding is there. It's pretty similar. So what are we going to do today? We are going to briefly discuss downloading and building Mavisdk server. I'm not actually going to do that. It's already done. It's like a 15, 20-minute build process. It's not quick. We will use the Node version manager to get our Node.js installation and our Node package manager npm. We'll figure out how to use grpc with Node.js so that we can communicate with the backend to our bridge. And we'll create a REST API on the other side of the bridge that translates those grpc messages into whatever interface we want. We're going to do some pretty simple commands: arm, disarm, takeoff, land. But you can pretty much extend it to any bit of the files or the capabilities in a Mavisdk server. So we're going to use npm's create React app. This is the biggest, most magic command in all of the presentation. This puts up all of the scaffolding and literally everything it takes to begin developing a full-scale React app. I will say it's relatively heavyweight. Web apps, while nice, pretty, easy to write, they are big. They are not going to live on a small embedded controller. You can run a React app off of Raspberry Pi though, so if you really wanted to, you could have a full GCS where your GCS looks like a Raspberry Pi running all this stuff and a tablet. All you need is some kind of router so that they can communicate. So we're going to assume that you have, I'm using Ubuntu 20.04. I tried to compile Mavisdk server on 22.04 and ran into some linking issues, and I'm sure they're going to be solved, but I was making a presentation, not trying to compile code. Well, was trying to compile code, not necessarily solve the problems. So we're going to go with Ubuntu 20.04. We'll assume that you have PX4 installed, mostly so that we have some variety of simulator. We'll be using JMavSim in this example. So Mavisdk server, a show of hands, who's used Mavisdk server or any part of like the Mavisdk stack in the past? Cool. So it's not going to go too in-depth with this one. You can follow their quick start guide for installing and compiling Mavisdk server. But TLDR, clone the repo, update submodules, build the code, and run it. I mean, it takes a little while, but on 20.04, it was no effort. It didn't have any problems at all. It was just a very straightforward installation. And the way that we're going to run this is the path to our Mavisdk server executable, which is kind of hidden. It's not in a really obvious spot in the build directory. And we'll connect to the drone via a UDP port, and we will define a port 50,000 for the other side of our grpc communication. So just setting up basic ports for communication there. And just to like kind of see everything working at this stage, assuming that you have just PX4 and Mavisdk server, can run the simulator. So make PX4 citl default JMavSim. Let that come up, and then we'll spin up the Mavisdk server, and we'll be able to see the two of them connect. And they are communicating over that UDP port 14550. It's just the default, but you can set it to whatever you need. And then this is where it's a little non-trivial where this Mavisdk executable lands. It is in build, default, let's see, source, Mavisdk server, another source, then Mavisdk server. Yep, you gotta go looking for it. But it is there, and we'll put on that UDP 14550, and we'll define our port of 50,000. And here we see our partner IP, that's just localhost, and we can see that we discovered one component with Mavisdk server, and it's listening for our grpc communication on port 50,000. So next up, we really just need to figure out how we're going to build this communication and convert it from something that's frankly a little tricky to use like grpc to something that any web developer can handle. So we'll convert that to that REST API. To start, you need to install all the node tools. This is really straightforward. Like, one of the nicest things about web dev is that large tech companies have put so much money into making this really, really easy. I had no issues on either 2204 or 2004 with these commands, and you can just go to their GitHub and they have whatever the most recent curl command is. You just pipe it straight into bash, source your bash RC, and all of a sudden you can run nvm, which is the node version manager. So we can run nvm ls remote to see which versions of Node are available, and we can install any one of them with nvm install and the version number. This makes it really easy to swap between a lot of different versions because the nvm, the version manager will actually uninstall and reinstall whatever version you want, so you don't have to worry about a lot of dependency issues or versioning issues. So just to see kind of what we get at that point, we have nvm ls remote. You'll see that there are a handful of versions of Node that have happened. I picked 18.4.0, but really I think best practice would be to scroll up here and see what this latest LTS is. And just go with that. They're well supported and you really don't have anything to worry about if you do. And then nvm install, in my case, v18.4.0. Yep.
I got a question there. At this point, is the SIM already connected to the master?
Yep, it's still talking. We can just leave those running the whole time.
How did it, so the SIM obviously is running on a local host,
Mm-hmm.
in this case.
Yeah.
But when it's running on a real machine, so you got the drone,
Mm-hmm.
and then you got the, let's say the server is running on like local Mac.
Mm-hmm.
How do they find each other?
Yeah, you can either just, so for that, I would, let's see, how am I doing this? You can essentially just set, so right here, I guess we, hang on, bring that down. Instead of just putting UDP 14550, the drone is dialing into this. It's trying to make a connection with this UDP port. So all we need to do is expose it somewhere on the network. And what you'd have to do on the drone, oh, sorry.
So as long as they're on the same network, they find each other.
Yeah, there might be a little bit, I might be oversimplifying a little bit, but it's not too bad. It just ends up being like getting your URL strings correct and everything will just start talking. They've got the discovery pretty well figured out. I haven't had really any problems, and we'll just leave this running the entire demonstration and it'll stay connected and everything will connect and disconnect just fine the whole time. So next up, we need to install the dependencies for this gRPC bridge. So the way I've got the talk structured, all these major bits are tagged. I'll publish all the source code after the fact, and you'll be able to just go in, take a look, check out the slides, check out the tags, and hopefully just be able to follow through and kind of see what changes have happened. Because there's just a lot of code to go through if we actually do it all by hand here, and I'd probably mess it up. So we'll just run npm install the dependencies for the project, and what that looks like, just for example, let's say we wanted to run npm install express. You'll see it's already got it, didn't need to do anything, and the way that we can confirm and see what we've installed is just looking in our gRPC bridge. We have this new file, package.json. Package.json is just telling Node which dependencies it needs. So here we've got gRPC, cores, which is cross-origin resource sharing. It's so that disparate components on a network can communicate and not get blocked by, if you don't have your core set up correctly, your request will get rejected from the browser. For right now, we're just gonna open them all the way up and we'll take a look at that in a second. And then we'll also install Express, which is the actual REST API server that we're going to use. Express will allow us to set up all of our endpoints like /arm, /disarm, and just connect over the network that way. So next up is creating the REST side of the bridge. And we're already a good chunk of the way there. We've already got npm installed. We've already got it all ready to go. So we'll create, the way I've got my project structured, we'll create a Mavisdk REST side. Oh, hang on, here we go. We can take a look at what that actually looks like. One sec. All right, so we've got our source directory, and we've got Mavisdk rest. So what's happening here? We're going to start off by requiring that cores package because we'll have to pass it into our Express app. Require Express, that's going to give us the tool to actually produce the app that is listening on all of our REST endpoints. We'll set up a couple of JSON configs. These aren't really important right now, but if you start passing large amounts of information back and forth, you might have to change your settings so that it can actually deal with larger payloads. Like if you're trying to upload large files, you might want to up your allowable limit to like a few megabytes for file transfers. And then the express.json, we're not using it right now, but that's a really helpful library for parsing all of our JSON messages that we're going to be passing back and forth. Right now, you see I've labeled this const unsafe front-end URL, and I passed that into cores. What this tells us with the star is we are going to accept any communications from anyone, anywhere. Doesn't really matter. Yep. Oh, yeah. Oh, sorry about that. There we go. So what this will tell us is we can accept anything. If you wanted to change it to something a little more safe, you can say const front end URL. And we know that today it's going to be on localhost, so it'll be something like HTTP, let's see, I think it's just localhost 3000. And if you put this for your core's origin, it's going to only accept calls from localhost port 3000. It's not a lot for security, but it can at least keep people from just very easily and blatantly getting into your system and just making requests that they shouldn't be able to. So next, now that we've got core set up, we'll require our HTTP package and create the actual server that is going to run our app. So just HTTP create server, pass it that express app object, and we just get a server out. So for right now, disregard GPS, that shouldn't be here right now. But right now we'll just create an ARM endpoint. To create that, we'll do app.get. That means that we're going to be looking for a GET request. There's also things like app.post if you want to do a POST request and send additional data through a payload. So for right now, I think a big thing that I learned when I was trying to figure out how this all worked the first time is establishing that what I have is actually working the whole way through. So for right now, we can run node source Mavisdk rest, and we can see that it's listening at 8081, and we can actually test that. If you don't want to use any other crazy tools, you can test it over with a web browser. The nice thing about using GET requests is that that's what your web browser is just natively going to do. So if you do, it's really easy to test your stuff. You don't need anything special, but if you really want to, you can also do the same thing with, say, curl. So you do curl host 8081. And it probably would help. Oh, it's because I need to go to, see, that did not work. Of course it doesn't work because we should be talking to ARM. And we can see that we get that 200 OK status out. So at this point, we have a drone connected to Mavisdk. We have an interface so that we can talk via REST. So we really just need to connect the two sides together. So we'll build the gRPC side of this bridge. So we'll, in source, create another file, Mavisdk gRPC. We'll require the libraries that we installed via npm. We'll load the gRPC definition from the proto file. I can show you what that looks like. We'll create a class to actually manage some of this stuff and make it easy to make function calls. We'll create a client. What that client's going to do is it is the actual bit that's communicating over gRPC with the Mavisdk backend. And from there, we just need to create an ARM function for this Mavisdk drone class so that we can send the gRPC messages to the server. So we'll check out tag 3. Okay. And you see now that we've got tag 3, we also get this gRPC rest. So what's going on here? Similar to the others, we're just going to require whatever packages we need. So we get our gRPC JS and our proto loader. Now, this goes into a little bit more of like, what is gRPC? gRPC is just basically a list of message definitions so that both sides of this can figure out how to parse out the binary data that's going to be coming through the web connection. And the way you're going to find those is actually, I put a link for that. I think I accidentally deleted that. We have this Mavisdk proto that we can look at. And I've just added it here as a submodule. And it is just as they say, the collection of proto files for interfacing with Mavisdk. So what is a proto file? Well, like we said, it's just a collection of message definitions. And what we're interested in right now is we're trying to arm the drone. So we can see that we have this remote procedure call called arm. It takes a thing called an arm request and it returns a thing called an arm response. So we've got an arm request, which is just essentially an empty message because we don't need any additional payload to arm the drone. We just tell it arm and that's all that really matters. And we can also get this arm response that gives us this result that can either tell us success or failure. We're not going to be doing anything with that today, but you can get that information back out. So at this point, we have gRPC, we have an ARM function. Let's see, actually, we'll go back over here. Sorry for making everyone motion sick. So here we load that proto file, action.proto. We'll just output where we're looking because if it doesn't find it, it'll just fail. We'll actually load that proto file in so that we can use gRPC. I just set a const for the host name. There's that port 50,000 that we're using in our Mavisdk server. And from there, we just create this Mavisdk drone class. The constructor is in Node, well, I guess JS, is just called constructor. And we can define things like this dot action. So this Mavisdk drone instant dot action is going to load all of the information that it takes to deal with the messages, and then it will create the actual client that can communicate via gRPC. And to make one of these remote procedure calls, we can call it with this dot action client that we defined up here, dot arm. We know that we don't have to send anything because that arm request definition didn't have any parameters, and we need some kind of callback so that we can tell if anything bad happens, or just deal with whatever information we get back. Right now, we'll just do nothing if it succeeds, but we'll print out if it's unable to arm the drone. Or unable to arm the drone is a little funny because if the drone doesn't arm, it might not return what you think, because this is looking at an actual breakdown in communication. Like this would signal an actual failure. And if the drone is in a weird mode where it won't arm, then we may or may not actually get the response back. So just It's usually pretty reliable, but just be sure that it's actually working with your system the way that you expect before you just go and write a bunch of code on top of this. And then from there, now that we've got our RPC file all set up, all we need to do is figure out a way to call this. So we've got communication with the backend working, which is great. We've got a REST API talking to the other side of our bridge working, great. So all we've got to do is connect them up, and all that takes is instantiating a drone object in our REST API file and calling drone.arm. So we can see over here, that was 4, correct? Get those out of here. And all that really took is requiring that file so that we actually have access to the Mavisdk drone. Oh, one bit about the Mavisdk drone. We do need to actually export it from the module, otherwise we're not going to be able to use it. It just won't show up, it'll appear like it's not even there, even though it obviously is. Just module.exports Mavisdk drone and you'll be okay. So import your definition, instantiate an object, and then when we call arm, just arm the drone. So here we go, we can spin up our REST API. So this is just the REST API, there's still no front end, but that doesn't mean that we can't validate. So over here, we can say, well, let's just go back over here and refresh on ARM and see what happens. Did a little wiggle, and if you look over here, armed by external command. So at this point, we are communicating with the drone. We've got communication one direction, and it'd be a little more interesting if we could do just a little bit more. And fortunately, it's really not too hard to, because the logic for takeoff, land, and disarm are the same because they all live in the same action proto file. And if you look at their definitions, they all take an empty set of parameters. They all return the same success or failure. It's really easy to just extend this and do more. So it's kind of fun. Like, we've been working on this for 30 minutes now, and we are already ready to do a hop test. So from a browser, we'll check out here. We can see we've got arm, disarm, takeoff, and land. The definitions over here look essentially identical, to the point that I even copied and pasted the wrong code here because it's literally the exact same thing. So from there, we can go through on a browser. We can arm, and try and take off. I bet we can land. And it'll disarm itself. There's not really a need to do that. So at this point, we can do communication one direction, and we can send commands. So really the next step, I was a little on the fence of like how to present this. I think it's easiest to understand if we just keep building from the back to the front. Instead of implementing all the way to the front end and then going back and implementing GPS, let's just go ahead and see how we're going to implement the telemetry and actually receive information from Mavisdk server over gRPC. So we want to get the gRPC telemetry from the drone. How does this work? Well, gRPC works over HTTP2, which is a persistent connection, so we can create these long-lived channels to just continue to send data from one end to the other. So the GPS data is not in the action proto, so we're going to have to import the telemetry proto so that we can get access to all of the other calls. And then we'll need to subscribe to the position, which is a little less obvious than how it went for ARM, because we've got to set up a handful of calls because the GPS message is going to tell us if it got data, if it's trying to close, if it got an error, just kind of a handful of status messages. So we'll go ahead and check out tag 6. And now we instantiate a position so that we have somewhere to put the position. And we are able to call this subscribe to GPS function inside of the grpc file. So we're going to subscribe to GPS. What does that actually look like? Well, this is where things get a little weird with JavaScript, because these functions are going to be callbacks, and the definition of this gets a little bit unclear. So just right off the bat, if you're using a callback in JavaScript, const self equals this. We're going to use self in all the callbacks. We're never going to lose this reference to the object that we actually want to call it on, and it'll give us the ability to actually update state information down here. So at the top, similar to before, we just include the telemetry proto file, exactly the same. Create the telemetry client, exactly the same. And then we just set it up so that we can look for GPS calls, and when it sends data, we'll print it out so that we can make sure it's working. And we'll update the position of this object, which is now called self, to the information that we got. We can also see if there's an end, if Mavisdk decides to close the connection. We can see errors, and we'll also get status messages, although I really haven't seen many of those coming through Mavisdk. So just to verify that that's working, again, I just love testing at every stage because then you can tell when you broke something. There's that console.log printing out our response. So at this point, we are pulling information from the GPS into the bridge. So really, all we need to do now is make the telemetry available over the API. So we'll just create an endpoint so that we can retrieve it as often as we want. For this demonstration, we're not going to push data to the front end. You can do it over a variety of mechanisms. Like you could create an API on the front end if you want to do it that way. You can create a WebSocket, choose your favorite. There's lots of ways to get it done, but just kind of out of the scope of what we're doing right now. So we will verify that we can actually get the data. So here we took out the call to print because it's just going to be spamming now, because we really don't need it. And why don't we need it? Well, over here in our REST API, we've simply defined another get endpoint called GPS, and we'll just send that drone object's position through the response. The nice thing about this is the networking part's really, really easy. It's super easy to pass data around. So what does that look like? We'll run it again. And if we go to a browser, localhost 8081 GPS, we're getting GPS data to a browser now. And if we refresh, we can see it update as it's spewing the data in. We can see all the calls, so it looks like that part's working pretty well. So at this point, we can use our backend just through a web page, hitting the endpoints directly to do a hop test and get GPS data. But obviously, like the whole point of this is to build a web page-based GPS, not a curl-based GPS. That was not the point. So we're going to now create the React server. And you might ask, like, why did I choose React? Well, frankly, I had friends who knew it, recommended it, and then gave me a lot of the reasons why I'm going to give you right now. It supports large web pages that remain very responsive with huge numbers of components. Now, there can be some nuance in making sure that your rendering times stay really fast, but the standard for a React app is that it's rendering at 60 frames. And most browsers actually have tools. The React dev tools will tell you when your frame rate drops below 60 frames a second. And it won't break the app, but it lets you know when that user experience is going to start going down. There's a huge community support for this project. I know on a lot of our projects a lot of people is 10,000. Well, a lot of people for a web application is 500 million. Like if you look at the number of downloads from a lot of the Node tools, they're getting hundreds of millions of downloads every year, and it's just on a totally different scale. Because there are so many, or because web is so prolific now, there are tons of new developers. Like I said earlier, it's hard to find someone who can write anything for QGC. It's really easy to find someone who can flesh out a good-looking professional web page. There's already a bunch of open source components created. The NPM has its own libraries that you can check out, and they have it is endless components that you can just pull and use. So you really don't have to create a whole lot of new stuff. I mean, just for example, we're not doing it here, but if you wanted to include a map, for example, there's a React plugin, a React package for, it's called Leaflet, I believe. And you can literally put a drone on a fully functional, interactive, zoom, drag droppable map just by passing those coordinates that we have. And it's really not much more effort, and all of a sudden you can see where the drone actually is. And as of right now, well, as of last year for the first time, it became the most popular front-end framework. Like, it may be a Facebook product, but everybody uses it. It's free, open source, and everyone has established that they will be continuing to support this platform. It works really, really well. So this is where everyone's favorite magic happens. And I'll actually go through this step and show you what's going to happen and what you're going to end up with. Because it seems a little weird that you're gonna create your whole scaffolding for a web page in one command and it's actually going to work. But it's pretty impressive. So we'll just to make sure that we don't totally ruin anything, we'll back out one directory, npx. npx came with that nvm install that we did at the beginning, so no need to install anything new. Create React app, and we'll do live test. Oh, and they don't allow uppercase, so live test. It's gonna just spit in there for a minute. I'll do some stuff, download a bunch of dependencies, but the next thing it's gonna do is pop up a fully functional React web page. It's almost too easy. It's kind of weird. So while that's running, let's see, it usually doesn't take too long. Let's see, just real quick, I guess while we're waiting for that, does everyone feel good about where we are, kind of understand how we got here from nothing, basically? What's that? Oh, yeah. Yeah, npx create React app, and then whatever you want to name it, but no uppercase. There it goes. Builds everything. And we can run it with, so this is the brand new one, cd live test. We run the React app with npm start. We'll spin it all up. Give it a second to load. There you go, there's a web page. That was one command. And you got everything that it takes to start building this fully fleshed out design. So just to verify that that's what we're actually seeing over here, we'll see, here, we'll do, oh, nope, I'm in the directory. Get rid of live test just so it's not in the way. But now we've got this GCS front end. I just ran npm create or npx create React app GCS front end, and we end up with an app. And this is what that whole app looks like. It just loads. It's got their image. It can deal with all of, it's your standard HTML. And if you haven't used React before, it uses a language called JSX, which is kind of, it's a little weird to get used to. It's like this hybrid combination of you're writing JavaScript, but then all of a sudden you have some components. But the reason this stays manageable is that you can create small, self-contained components that you can reuse all over the place. So you don't have to continually grow your JavaScript code base in like a file that you're either going to pack and ship up somewhere. It just all, it feels very, it feels very natural. From a C++ background, writing web applications in React does not feel like web development. It feels like I'm writing a program with the same classes, the same architectures and structures that I would have used the whole time. Just the output for this one happens to be a web page. So now that we've got that very simple app running, the one bit that I do want to say is, it is just stock HTML that you're going to be serving up front. So so you really want to do something to make it look a little better. And a library that I like to use to do some very simple styling is called style components. And you can install that with the same, everything is always just npm install the thing you want. So we'll create a new component directory, and we'll actually create this arm button component so that we can use it other places in our app. In that file, arm button, we will create a function called arm button. And what that button is going to do is return a styled button wrapped in a div. One thing to remember with React components is that when you return a React component from one of these functions, it has to be contained in a single tag. And the way that you just deal with that is you can wrap everything in a div if you want to. So you just put open div, close div, everything else you want, and it'll get exported correctly. And then from there, we just need to create that arm drone function so that we can make that get request to the front end, or to the back end, export the arm button similar to how we exported the drone class in the other file. And from there, we just need to import that button we created into our app.js. We're gonna make it super simple. It's gonna be a blank web page with a handful of buttons, not doing anything special here. So we'll just paste it right into the middle and spin the app up with start. And at that point, we've got an arm button. So we'll check out v9. And here we've got our components directory with the arm button. So one additional thing, actually we're not using state here, so that can go away. But we have this import from styled components, and we'll style our button so that it's not just a plain HTML black and white sharp cornered button. It can at least look a little bit nicer. And we'll create our arm drone function that all it's gonna do is it's gonna use fetch, because that's what you use to make requests in JavaScript. And it's just gonna hit that arm endpoint. It will use a get request, and we can set what kind of response we'll get back. Here we'll say, we're gonna expect some kind of JSON, but for us, we're not really even dealing with that right now. Here's that arm button. So this is what actually creates the component. So we come in here, this use state we'll get into a little bit more. It's not relevant here, that's left over. That shouldn't be here right now. But we'll use it over in the GPS information, so we'll still get a taste of that. Because this state information is how you can get information from these variables to appear and update in your web page. But kind of like we said, all you need to do is return a button. On click, it's going to call arm drone. That button's going to be labeled arm drone, and we'll just export the button. And at this point, we'll spin up the back end because we have a full stack web app now. We'll npm start. Give that a second to spin up. And look at that, we've got an arm button. Actually, I'll come down here. and that's being served from localhost 3000. That's just the default React app. We have an arm drone button. So it doesn't really do a whole lot right now because the drone's just armed and sitting on the ground, and JMavSim doesn't really show the propeller spinning like Gazebo does. But if we take it one step further, we just do the exact same thing for takeoff, land, disarm. And for right now, I'm just creating those in their own independent files, but like I said earlier, it feels a lot more like writing like a C++ app or something like that. It doesn't feel like web, and you can make these components much more reusable. Like a technically better way to do this would be to create a single button class, and you could just pass in a handler, give it the text. You could have some very expandable general components that you can use all over your web page. And with that, we can update one more time. Spin it all up again. And here we can just see to verify we've got arm, disarm, land, and takeoff. And right now I just shoved them all on the web page. They're just going to stack up. They're not going to be pretty, but they'll work. Start the whole thing up again. Again, it keeps opening it right over the presentation. So we can do that same hop test, but we can do the whole thing from a web page now. So we can arm the drone. You can take off the drone. And we'll just go ahead and land it. So, I mean, we're less than an hour in and we're hop testing a drone. Like, it doesn't totally suck. But wait, there's more because we've got GPS information to learn from. So, GPS information, it's nothing too crazy. We do have to take a little bit different approach because we need to set up a mechanism to actually communicate with the backend and set it up so that we don't have to continually click a button to refresh position. That would be silly, and like I said, we're not going to be pushing position right now. That's a little outside of the scope of this talk. But we do get exposure to some very important features in React. The two that I think they're probably the most common ones that I use are set state and use effect. And what this does is set state gives you variables that you can render, values that you can render into your web page. And when this state gets updated, your web page will update as well. So a lot of this refreshing, updating is all handled by this React rendering engine, and it just does a really, really good job of it. We can also use use effect. I haven't done a lot of I haven't been in web dev that long, but if you have been longer, this is essentially equivalent to the older call component did mount. It's basically once the component mounts, everything is ready to go. It calls this function either once, or you can give dependencies so that it will continue calling it when different state information is updated. From there, we'll just import this GPS information into the app. In this example, it's just a very basic label. Called it a table. That's not quite accurate because it was trickier to do, and I didn't feel like the formatting right now, but the important part is that we get the information there. And then we just create this GPS table component in the app. It's self-contained. It'll just live there. It'll keep making calls as it needs to update information. And I'll show you how that actually happens. All right, so I made a component called GPS chords. It lives in that same components directory. So we've got our styled components again so that it's not just an ugly black and white box with sharp corners. We will define that endpoint. We need to make a call to GPS. Remember that if we make a call to that GPS endpoint in a browser, we actually get that payload back. And we do need to use that use state information here. And to start, we're going to just initialize it to all zeros. We're going to assume that we don't know anything about the state of our GPS information. And the way that this set state works is we get a variable that we can render in the page and a function that we can use to set it. Notice that this is not, this is not var, this is const. Like these are not mutable. The only way that you change GPS position is by calling set GPS position. So we have a state that we can store. And you see down here we have my pretty text styled component that will display the lat, long, and alt. But right now it's not going to do anything. We need a way to actually update it. And for that, we're going to use the use effect with a set interval. So use effect, all this information is going to go through, the component's going to mount, and we are going to call this function one time. If we wanted to call it more than one time, we could put dependencies on here. So let's say we wanted to do something else every time the GPS position changed, we could create another use effect with, whatever. And for that last, we'll just ignore all this stuff because we're not going to put anything there. But in these brackets, we would say just GPS pause. And now every time GPS pause gets updated, whatever function is defined in the use effect, whatever we would define down here, would get called. So if you need to have some interactive, maybe not interactive, but just you need some larger or farther reaching updates to happen, you can do that logic that way. But all we're going to do for now is we'll set an interval. We'll call it async because we need to wait for a fetch request. So await's another one of those keywords. We need an asynchronous function. And we're just going to make a call to the REST endpoint. We are going to receive the JSON payload back. And we will just call set GPS position, this function that got returned by set state, with that new information, and we'll do that every 500 milliseconds. So every 500 milliseconds, go get GPS information, update the position, that will get rendered into the web page. So we'll go, start it back up. See, we're getting all those hello GPSs, because that's still in there and just spamming right now, but there you go. We have lat, long, alt, and if we do a hop test, I'll actually come down here. Look at that, it all updated there. It's so easy. Arm the drone, take off the drone, you should be able to see the altitude climb, and we can just keep taking the drone off to get a bigger difference so it's easier to see. Yep, so we're at 495 now. Land the drone, we should see it go back to that initial altitude. And the thing that I really like about React is how everything is it's self-contained. It's not like the logic for this GPS component is going to obfuscate or complicate anything else. It's self-contained in its own file. If you wanted to add more of these somewhere else, you definitely can. It makes the reuse of your code super, super easy. It feels much more like writing it feels more like writing a program than it used to feel like writing a web page. You get to use a lot of the skills and knowledge that you have of standard programming to develop something that's responsive and reactive, and honestly just is a lot more fun to write. So just to briefly recap, what did we actually learn here? We learned the commands to run Mavisdk server, or to build Mavisdk server. We learned to communicate to the drone and from the drone using grpc. We built out a REST API so that we can communicate with the drone and actually send information to it over a standard interface that any web dev could use. We built the React app, and we used the React app to send data to the drone and retrieve data from the drone. So I guess it's a really simple example, but it's most of the things that it takes to actually build up a more fully featured GCS, because now if you just look through the protos, look through the proto files, figure out what information you need to send, import that proto file that you need, send the information, create a REST endpoint, and from that point on, a web dev can just jump in and they can run. They know how to deal with a REST API. So it takes a lot of the obscurity of the gRPC side of Mavisdk server and turns it into something that's just really clear and easy to see. And the repository is private right now. I'm going to make sure that it's all cleaned up and looking good, but it will be posted here at, I am Zinad, it's Dan Nix backwards /webgcs. Yeah, that'll have, I'll get the slides in there, I'll get everything there, and yeah, all the tags will be there. So if you want to diff the tags, see what changed along with the slides, I'm hope that that's enough, but if not, always feel free to reach out. I think I had my email on the first slide. Yep. So, yep, that'll all be available in the repository. So I guess, yeah, we're finishing up. Are there any other questions? How would I do this? Yeah.
Have you considered what this architecture would look like if the web page is being hosted on the road itself?
If you've got a Pi, it looks the same. It's like, that's one of the cool parts about this. Like the Holybro, oh yeah, the Holybro Pi flight controller is, I mean, it's kind of a prime opportunity for it. Like I think that you have the chance to host essentially everything that it takes to run your drone. Like there's no reason that you couldn't have just have the Pi serve everything. And as long as you can access the drone from an IP on the network, that it's just serving a web page, it's network traffic at that point. Now, one thing that I would say is the amount of payload that it takes to deliver the web page can get pretty large. So when you're close to the drone, setting it up, like maybe the drone's on the table and I'm getting everything ready to go, that's not going to be much of a problem. If the drone is 1,000 feet away and on the edge of Wi-Fi, you're probably going to start dropping stuff.
Yeah, that was going to be my follow-up question was, I'm not a big web person, but we've set up a Mongoose instance running on board our flight controller, and we use it mostly for diagnostics, so streaming video and IMU data back, but we're looking for making it a little bit more advanced, a bit more slick.
Yeah, and there's definitely options. Like I've found, so with this setup, I'm able to run. So one issue with Mavisdk server right now is that it is one instance per drone. I have set this up in a set of Docker containers that spin up 10 of them. You can communicate with 10 drones, no problem. So running a single drone, like Mavisdk server is pretty robust. So as long as what you're communicating is Mavlink, it's pretty easy. I haven't done a lot of testing with like what happens when you really start pushing. You know, you put the server on the drone and go fly it, like what actually happens there. I haven't done any work with that. But it's definitely, the way I see it, you could have just very simple configurations. Like it'd be cool to just log on to the drone's Wi-Fi and run a config, or run a calibration. There's no reason that you need to spin up a fully separate GCS just to turn it and flip it.
That is exactly what we do.
Yeah, we can talk after.
Yep, okay. Thank you.
Yep. Any other questions?
We got a question here on the chat from
Yeah.
Daniel. It says, "Thank you for the presentation. Have you tried this approach on real drones?"
On real drones?
Yes. Have you tried this on real drones?
Yep. Yeah. 10 n equals 10 works pretty well. So 10 real drones had no problem, because really what you're measuring there is, can Mavisdk server maintain just a Mavlink stream? Like it's just maintaining Mavlink communications at that point. So it's no more traffic. Really, we're offloading a lot of this UI and a lot of the heavy lifting onto a separate computer. So as long as whatever machine you're running it can handle it, you're pretty good. You're literally just using Mavisdk. Any other questions?
Test. All right. So the deployment of this still requires you to have Mavisdk running on the GCS. So it's not 100% web deployed. Have you thought about or considered using something like WebAssembly to deploy it like 100% from the web? Or is that even possible?
Yeah, the biggest crux on this is figuring out where you want to kind of like hand off your Mavlink communications. Like, if you don't want to deal with Mavlink at all, you can just serve the web page from the drone. But now you're serving a heavier weight payload, and the whole point of Mavlink was to maintain these good comms. Now, there's other libraries out there that can communicate Mavlink, and there's no reason that you couldn't do something like that. Now, this is, the objective here was not like, I'm not saying that this is like the optimal primo solution. This is a really good spot to start so that you can quickly get prototyping done. And if you're just trying to see, or if you're trying to answer the question, does a web-based GCS work for us? It's a pretty quick way to get started and at least kind of test that use case out. Now, one thing that I do like about this is you can have your REST API sitting on this machine, and I could have my front end living in the cloud somewhere, you know, put it up on a server, and as long as I have decent communication between the two, between my server and my local computer, I can be anywhere in the world, load the web page, and it's just going to talk to the drone. So it starts working towards, I think Lorenz made the comment, it's not so much about being able to take a drone off here, and now it's about being able to take a drone off in Philly right now. Like, and with this architecture, that step, as long as you have the backend living in Philly talking to the drone, that step is really trivial. So yeah, the distributed application is, I haven't done much of that. Everything I've done with this has always lived on the same machine. But I am not at all concerned that you can start splitting stuff up and replacing components. Yep.
Yeah, we had been messing around with some of this. We're doing cellular communications on our drone, and so the drone will connect to, say, Verizon or AT&T, and it's going to get a non-routable IP address. Mm-hmm. And if you're out in the field and you've also got your GCS computer and you hook it as well, it's the same problem, and they can't talk to each other. So we have to set up a VPN, essentially, to get the two talking to each other. Okay. But with this, we just put a web server out there.
Yeah, everything can dial into the same
talk
spot.
To that, and so it's really nice to avoid having to use VPNs and things like that.
Yeah, I mean, you're basically just like, you can punch a port through, and you're just communicating via your back end, or your back end communicates to the front end, and everything is just, it's all set up there. You just need to make your initial dial from the right direction. Cool. Well, thanks everyone for coming. I appreciate your time, and if you have any questions, feel free to ask. Catch me after the show, or just email us Dan@nixworks.us.